Good morning and good afternoon to everyone who has joined. My name is Andrea Berg, and I am your host today for our 2025-2026 Winter Weather Outlook webinar. I am joined today by my colleagues Eric Jenks, who is one of our long-range weather risk communicators, along with Nathan Hamlin. He is also a long-range weather risk communicator, and Stephen Strum, our long-range senior weather risk senior manager. A few housekeeping notes before we begin. We are recording this webinar. We will send out a link with all attendees and everyone who registered when it is available. If you have any technical difficulties throughout this, please contact me through the chat feature, probably located on the right-hand side of your screen. And we have reserved some time at the end for any Q&A. So please use the Q&A feature of WebEx to ask those questions at any point throughout the presentation. So with that, I am going to turn the presentation over to Eric.
Thank you, Andrea. My name is Eric Jenks, and I will kind of go through start with a quick look at the agenda. We'll review last winter, the highlights of winter 2024 and 2025, and then we'll go over some of our forecast techniques, looking at ENSO and different analogs that we can use statistically, and just to take a look at what happened in the past that could happen this year. We'll also take a look at potential polar vortex outlook, and then we'll mix in some of our computer model projections, dynamical models that use current ocean and atmosphere observations, and use that to also go forward to make a forecast for this upcoming winter season. So then we'll focus on our seasonal outlook, the winter of 2025-26. This will look through November through March, and include a look at our heating degree day outlook for this winter, and a verification of our previous winter outlooks. And we'll tie that all together with how the upcoming winter will impact various industries such as utilities, aviation, transportation, and offshore. So we'll start with a look at 2024-2025 winter. And last winter was highlighted by a weak La Nina that developed during the winter season that peaked in January, so midwinter was when the peak of the La Nina. It wasn't a strong one, generally a weak one. Over the course of the winter, we generally saw a stronger jet stream going across kind of the central third of the U.S. Away from the Canadian-Mexico borders, strongest jet stream near the East Coast. In terms of temperatures, November and March were pretty similar, where we've had above normal temperatures across the central and eastern half of the U.S. and a little bit cooler in the west, especially near California. Coolest stretches were in January, where below normal temperatures were in place across much of the U.S., and that continued into February across much of the northern U.S. Overall. Biggest storm impact overall for the winter season last year was a winter storm that impacted the Deep South over January 21st and 22nd, that dropped almost a foot of snow in portions of the Florida Panhandle, brought several inches of snow into New Orleans as well. Other impacts, highlights include heavy mountain snow across the Pacific Northwest, especially Oregon and Northern California and into the Northern Rockies. We also saw above normal snowfall throughout the winter across the Central Plains through Ohio Valley and portions of the Mid-Atlantic. And we also saw heavy lake effect snow throughout the winter over parts of the Great Lakes. As for the general temperature departures for last winter, you can see above normal for much of the country, warmest anomalies across Texas through the lower Mississippi Valley, as well as across Minnesota, Iowa through the western Great Lakes. But warm anomalies extend through the East Coast overall. The one area where there was some cool anomalies was across portions of Montana into the western Dakotas, generally near to slightly above normal otherwise in the west for the winter season. Precipitation, you can see dry conditions up and down the East Coast, as well as across South Texas through the desert Southwest and to Central and Southern California. Also dry in Western Washington, but in between there was increased rain and mountain snow from Northern California, Oregon, through Idaho and into portions of the Northern Rockies. Also generally saw wetter than normal conditions across the upper Mississippi Valley into portions of northern Michigan, as well as across Oklahoma, the lower Mississippi Valley, and into the Ohio Valley. Breaking it down by month, you can see November, as well as March, as kind of discussed earlier, pretty similar outlook where warmer across the central and eastern part of the U.S., cooler in the west, did turn a little bit warmer in March in the northwest with the cooler anomalies focusing across California. For December, near to above normal temperatures across the entire country, with the warmest readings across the Rockies and the plains, not quite as warm along the immediate East Coast. And then January, you can see the more widespread cold anomalies impacting the U.S., especially the central southern plains through the Ohio Valley in the southeast, where the coldest readings are. Not quite as anomalously cold near the immediate Canadian border in the northern plains, as well as near New England. And then February, you can see the cold shifting back towards the northern Rockies into the Midwest. Does extend a little bit into the southern plains as well. The desert Southwest and then the Southeast, generally warm conditions, did return during the month of February. And then precipitation-wise, you can see November pretty wet across California, Oregon, through the northern Rockies, as well as across a good chunk of the central U.S. Was dry from South Texas through the east. December, generally our active storm track was from the Arklatex region of the lower Mississippi Valley through the Great Lakes and into the Northeast, as well as across the Northwest once again, dry across the Southwest and the Southeast. And then we saw dry conditions really take hold across the West in January, as well as across much of the East and the Great Lakes. Wettest conditions from the northern high plains through Texas and then portions of Florida. February, the wet pattern returned to the Northwest and lingered across kind of portions of the Ohio Valley into the lower Mississippi Valley, drier southwest of the Midwest and along the East Coast. And then finally from March, wet conditions were developed across the upper Mississippi Valley through the Great Lakes and the Northeast, drier across the South, still some lingering wetness across the Pacific Northwest. As far as snowfall, you can see one of the rare years we did see snow extend all the way to the Gulf Coast, from, you can say, Houston through northern Florida. But generally, heaviest snows near the Great Lakes and near the Rockies and the mountains of the Pacific Northwest and the Sierra Nevadas. In terms of anomalies, you can see much of the country saw above normal snowfall, especially central plains through the Ohio Valley, Mid-Atlantic, and extending into the southeast, as well as across central eastern Oregon into Idaho, far northern California, northern Nevada. And then you can see the signal from the Great Lakes where we did see enhanced lake effect snow, especially in upstate New York and Michigan. The one area where we did see below normal snowfall was a patch between the Dakotas, Nebraska, through southern Minnesota, Iowa, and into northern Illinois and southern Wisconsin. Recent trends, so looking now more at the short term here, going back to last August or this August, we have seen abnormal temperatures during the August-October timeframe across much of the country, especially from the Rockies through the plains in the central U.S., near to below normal in the east, and a lot of that is driven by a cool August that, especially along the East Coast, but did extend through the mid-Mississippi Valley into the central plains, with the warmth in August favoring across the western half of the U.S. September, pretty widespread in terms of warm anomalies across the U.S., with warmest anomalies in the Northwest and the Northern Plains. Not quite as warm near the immediate East Coast. In October, the core of that warmth has shifted a little bit further eastward into the central U.S., with cool anomalies beginning to develop along the West Coast, and not quite as warm once again along the immediate East Coast. As far as precipitation, it's generally been dry the past 3 months across much of the central and eastern U.S., with a wetter overall pattern favoring the west, and a lot of that is carried by a much wetter October across the west, with some tropical moisture getting sucked into the portions of the Four Corners and bringing kind of influx of more tropical rains to the region. And we've seen some of those rains extend into the northern plains where there are above normal precipitation over the past few months as well, but otherwise quite dry across the remainder of the central and eastern U.S. And then the final thing I'll cover is going to be look at when the coldest periods occur in various parts of the U.S. You can see left hand or on the top here, you can see the oranges indicate where the coldest 90-day periods begin earlier in the winter, and then the blues in the Northeast and the Great Lakes where they occur later. You can see in the west and south central U.S. is closer to a November 23rd start to the 90-day period, and it's for the Northeast, you're closer to December 9th or later for the coldest 90-day period overall. You can see on the bottom here, look at the past 10-year averages for December, February, and March. You can see the past 10 years, there's been quite a bit of a warm signal across December, across the entire U.S., but especially central U.S. through the Northeast. And then you get to February, you see warmth still holds in the east, but those colder anomalies developing in northern plains, northwest, that does linger into March across the west. And that is kind of showing a little bit of a tell that the colder 9-day periods may be extending a little bit further back in time in terms of when those 90-day periods began. So what may have been beginning, say, December 1st in, say, the upper Midwest is now closer to December 3rd because it's getting colder in February and March and not as cold in December. And with that, I will turn things over to Nate, who will go through our seasonal forecast.
All right, Eric. All right, Eric. Thank you very much. A lot to go over here, so let's get into it. And first, we'll go over what influences a winter season. And ENSO is usually the largest piece of the pie, especially when the event is strong. Typically around 40%, but if it's a strong event, it could be higher. If it's a weak event, it actually could be a little bit lower. So an average maybe 40%. And then the polar vortex, depending upon how strong it is and some of the impacts that whether they get to the surface and get into parts of the country, that could be as high as 30 to 50%, or it could be lower than that. And other subseasonal things like the Madden-Julian oscillation, the MJO, snow cover, and other things out there can have some impact, 10%, maybe even a little bit more, depending upon how many events there are. And then taking into account those 10-year trends that Eric just discussed, we have a pretty good skill at showing what ENSO is going to do. We have pretty good skill identifying the trends and looking back, but it's a little bit more difficult dealing with the polar vortex and especially the other sub-seasonal uh, indices when we look at it from a seasonal standpoint. So trying to predict what's going to happen with some of those during the midwinter in October is pretty difficult at this juncture. But all those kind of bake into the cake, so to speak. So let's take a look at the main seasonal drivers. And on the right-hand side, you'll see a map that shows sea surface temperature anomalies as predicted by the ECMWF model during the winter season. And where they see the oranges and the reds, that's above average or warmer sea surface temperatures. And we see the blues, that is below. There's a lot more red on the map these days, but there's a few areas that matter a little bit more. And if you look at the area west of South America along the equator, see all those blue colors, that's indicative of a La Nina. And we're going to have a weak La Nina. It's kind of central based. And what that means is that the coolest anomalies will be away from the South American coast and maybe a little bit closer to the date line. And that can kind of change things up a little bit, how the La Nina can behave. And then that will probably peak late this year, sometime in November or even December, and then weaken during the rest of the winter season. And another thing we like to look at is water temperatures in the North Pacific. We call that the Pacific Decadal Oscillation, or the PDO. And basically what that means is that warm water is in the North Pacific and then there's relatively cooler water up against the west coast. And you can see all the reds that are pretty far away from there. So we do have a negative phase this winter season, and that is forecast to predict or to last throughout the season. And on the right-hand side in the Atlantic, we are dealing with warm North Atlantic Ocean temperatures. So we call that a positive Atlantic multi-decadal oscillation. And sea surface temperatures are pretty important as to determining the pattern drivers, and they can yield some clues as to what might be coming. Let's focus in on ENSO for just a moment. And here's the ENSO forecast from modeling centers all across the world through June of next year. And we're right on the cusp of La Nina, and you can see with the thick red line is the model average, and pretty clear that is on the La Nina side of things, but it is just barely there, just over the line of 0.5 degrees Celsius below normal. And then by the time we get to January, especially April, you can see the rapid weakening trend that we'll be experiencing, and we could be knocking on the door of El Nino for next summer. That's pretty far away, so we'll see how all that evolves as new models come in during the winter season. So let's take a look at analogs and how we describe analogs as average weather conditions from previous years with similar ocean temperature patterns that we anticipate this winter season. And 10 years on the right-hand side, those are our top picks that are closest to this year. Notice here number one is last year. So we are anticipating similarities to what occurred last year. And you can see how they fit in on the ENSO scale. Note the weak La Nina between minus 0.5 and -1 that peaks during the early part of the winter season, and then the weakening as we get towards the latter part of the season. There are some models that faster or slower than that, so we take into account potential differences in what we expect with our analogs. And if you take a look at the sea surface temperature analogs of what was actually observed that year, you can see the La Nina with the cooler water in the Pacific, west of South America, and then you see the warmer water in the North Pacific with cooler water up against the west coast. So that all checks out. Then we have the warmer water in North Atlantic. That also checks out, but also want to call attention to the warmer water in the Western Pacific along the equator up to about 20 north. Some pretty warm water in there, and that can drive patterns quite a bit. So we made sure that was accounted for as well. And taking a look at jet stream analogs through the winter season, this is kind of similar to what Eric showed earlier from last year. Note the stronger jet stream winds. It's more in the northern half of the U.S., but some of the green stick a little bit more down into that central part away from the border as well. So we anticipate that jet stream to be able to will be in the north for a while, but it should be able to sneak down here and there. And then look at the blue winds. Those are weaker jet stream winds. Usually you get warmer and drier weather close to that. And that's been kind of suppressed down into central Mexico through the Gulf and off of the southeast coast. So that's pretty similar to last year for the most part. And if we take a look at weak La Ninas, they tend to come in a couple of different types. Some of them peak a little bit earlier in the season, like let's say November or December, something like that. And then some of them peak a little bit later in the season. That's more like kind of last year, where it's January or even February. And they can yield some different results. And we're taking a look at 500 millibars. This is where our ridges and troughs set up, and I can direct cold or warm to different locations in the country. And I'll call attention to a couple of features here. The early and late peak do have one thing in common. They do have, this is December, this ridging or high pressure here over Alaska and in the Northeast Pacific, and then a trough downstream across somewhere in Canada. The big difference is, look at the difference in strength of the trough during the early peak years versus the late peak years. You notice a little bit weaker in the later peaks and a little bit stronger in the early peaks. So what this means is that when you have an earlier peak, there's more opportunity for early season cold. And then, so we're going to have to watch out for that. But then at the same time, we could have a little bit more ridging in the south central part of the country. So maybe it's a little bit warmer there. If we fast forward to February, it does make a difference as well. So if you look at that area in the Northeast Pacific near Alaska, it's still there. That ridging will be in play with the trough somewhere in Canada. That's still going to be a thing. So those two things are similar. But if you look at the ridging off the eastern seaboard, all those yellows in the eastern part of the country into the Northwest Atlantic, that's a lot stronger in the earlier peaks than it is on the later peaks. You know, there's only a little bit of ridging and more suppressed into the southeast. So we're anticipating this year to have an early peak. So it should be at least somewhat different than last year. Maybe as a result of that, we get more cold maybe a little bit earlier than what occurred last year. So even though we do have those differences, we still think it's a pretty good analog, and I'm here to tell you it is proceeding almost precisely how it did last year. So look at some of the important features on the map between 2025 and 2024, and this is September. Note the big ridge here over Hudson Bay, and then another one over Scandinavia, and all that connected is exactly kind of what occurred last year. It's not, no 2 years are exactly the same, but the features are pretty similar in location. And in the Northeast Pacific, this ridge here near the date line, south of the Aleutians, and then the trough, eastern Siberia, all the way through the Gulf of Alaska, all that is in place. So that's pretty similar. And also, to have a pretty warm central U.S. in October so far, and will likely continue overall. And that was also similar to 2024. So we're getting off to a pretty similar start anyway. And let's focus in on some ocean temperatures compared to that year. While focusing on ENSO, you can see that the water temperatures are a bit cooler this year than last year. So it's a little bit stronger right now than last year, and it's getting off to a little bit faster start. So there's some difference in that through the first 19 days of October. But another thing, got to take a look at the warm pool out there, and note that this year's warm pool is pretty similar to last year, but note it doesn't quite extend as far east. Last year's kind of went closer to the date line. So overall, we think that warm pool will expand and it'll be somewhat similar overall. And usually when you have a warm pool like that, that allows the MJO to be a little bit stronger and it can get a little bit further east into the Pacific and reaching phases 7, 8, and 1. And when that happens, more opportunity for cold. So those warm pools can drive temperatures like or can drive the MJO and make it last a little bit longer into the Pacific Ocean. Let's take a look at the Great Lakes also compared to last year. And these are water temperatures are a lot of like Lake Ontario, pretty similar to last year. Lake Erie's even warmer than last year. There's still some water temperatures in the mid 60s there, and same in southern parts of Lake Michigan and Lake Huron. So pretty warm water temperatures, similar to last year. So as long as the Great Lakes remain warm going into the fall, that's going to increase the risk and intensity of lake effect snow this winter. Now, if we get some of these early cold shots, maybe the lakes will cool off a little bit faster and we can shut off the snow a little bit earlier than we did last year. So that's something we can watch. But this is kind of a warning sign that if we get cold air masses flowing over the lakes, they will be able to produce bouts of heavy lake effect snow. So let's take a look at some analogs and we'll compare them to model guidance here. So kind of get a sense of what the models are saying as opposed to our analog composite. And we'll take a look at it from November through March. And we'll start with November. So on the left, you have temperature anomalies. And on the right, you have precipitation anomalies. And analogs are on the top, ECMWF in the middle, and the latest CFS is on the bottom. And the analog solution has that warmth in the central US through the interior west and then the northeast as well, with this cooler look in the southeastern part of the country. And if you look at the ECMWF, even though the magnitude is not the same, the structure is. It shows it quite roughly in the same spot. And even the CFS shows it. So there's a pretty good agreement with the models with that point. Also, on the precipitation side, the analogs and the models both show below average precipitation across most of the South. And then if there's going to be any areas of above average precipitation, the Pacific Northwest, Northern California, and then parts of the north central part of the country towards the upper Great Lakes. The analogs are a lot drier along the eastern seaboard, but the models are a little bit wetter, and probably the models will come maybe a little bit closer. We'll see how that works out. And then we go to December. Again, the ECMWF and the analogs are relatively similar. Now, the analogs show a little bit of a colder look from the north central US through parts of the eastern seaboard, especially the northern plains, with warmth here in the Four Corners region through Texas. But if you look at what the ECMWF is doing, the structure is similar. So what it's telling you is that there's going to be an opportunity for some colder air in December. Sometimes the models don't pick up on it real fast, but they can hint at it. And I think that's what we're seeing here. The CFS, on the other hand, is much warmer. The analog precipitation is pretty busy in the interior northwest through the Great Lakes and then through the middle Mississippi Valley, with below average precipitation in Texas, Oklahoma, and then along the eastern seaboard. Pretty good agreement from ECMWF, although the magnitudes aren't exactly the same. The locations are, and then the CFS is quite a bit wetter in the northern tier. January, the analog solution, we're going with a colder look again, kind of like last year. We think there'll be some opportunities for some cold to get down. And this is where the models are going to follow along. So the ECMWF is much warmer, does show some coolness, but it's more or less in the western Canada and maybe hinting into the northern plains with a lot of warmth around. That's different than the analogs. And then the CFS is warm in the south, and it shows a lot colder look across most of Canada and into the northern part of the country. So that'll be interesting. And the analogs are a bit drier overall in January, more of a suppressed pattern, whereas the ECMWF and the CFS show a lot of precipitation across the Tennessee Valley through the Arklatex region and then parts of the west. And then the models are a little bit drier along the eastern seaboard. So it shows kind of an interior storm track as opposed to anything near the coast. And then February, below average temperatures in the northwest and north central part of the country, with the potential of it making down into Texas, and then warmth along the eastern seaboard. And then the ECMWF, something similar, except for that the cold doesn't get quite as far south into the central part of the country. And then the CFS kind of hints at the same thing, really, except for it's a little bit colder in New England. And the analogs are pretty busy in the Ohio, Tennessee valleys up through the Great Lakes, just like the models are. And then the models are pretty busy in the Pacific Northwest and Northern Rockies, but the analogs are a bit drier. So we do have some differences there. And then March, warmer look overall from the ECMWF and the analogs from the across the south and the east, with some cooler temperatures in the west and the north central part of the country from the analog solution. The ECMWF is not as cool, and the CFS has some cold, but it's more in the northeast. So as we get towards the further out in time, sometimes you get a little bit less model agreement, and that of course lowers your confidence a little bit. And then precipitation above average from the Ohio, Tennessee valleys up through the Great Lakes. All three solutions show this, the analogs and the models. And then below average for parts of Texas, and from the ECMWF, or excuse me, from the analogs and the CFS, the ECMWF is a little bit wetter. And again, note the green is away from the East Coast, so indicating a more or less a lack of coastal systems. So wrapping it all up for a 3-month average, above average in the east and south, barely. The New England, parts of New England and the desert Southwest will have the best chance of seeing above average temperatures. And then the north central part of the country, best chance of below average, according to the analogs. And then the storm track will be more or less for the Ohio, Tennessee Valley through the Great Lakes. And then parts of the northern plains and northern Rockies, dry across the south and dry in California. So what does La Nina do to snowfall? All La Nina years typically have increased snowfall in the north and less so in the Four Corners region in the mid-Atlantic. If you have a weak La Nina, typically that snow can extend maybe a little bit further south, and that's what's being shown here. And then if you have stronger La Ninas, less snow overall, and it's tucked in further north, and more or less you get a lot heavier snow here in the Pacific Northwest and northern Rockies. So that is what we're looking at here. And here are our analogs. A couple things stand out. Most of the winters have that snow across the northern U.S. But if you look at what's happening lately, if you look at the more recent ones, the ones in the 2020s, well, I've seen the tendency for these La Ninas to have snow a little bit further south. 2021, 2022, they all did it to a certain extent. Last year made it all the way to the Gulf Coast. Others did it. So we'll have to watch out for that. And when that happens, there tends to be maybe some areas in the north that miss out. And I think I'm a little bit worried about what's going to happen this year. If you take now 08, 09, and 2017, 2018, we're a little bit busier in the Northeast. So we'll have to keep an eye out for that. But most of these other ones were kind of missing precipitation in the Northeast and keeping that storm track away from the coast. So it's no guarantee we're not going to see any big storms along the eastern seaboard, but more analogs than not show that potential outcome. Let's talk a little bit about the polar vortex here. And a strong polar vortex is more circular. It sits right at the top of the pole. And that keeps the coldest air all bottled up at the higher latitudes. And note that little jet stream, that's about 60 degrees north, those west to east winds that keep it all bottled up, everything all tucked in. However, you can get a weaker polar vortex. And then what that means is it can be broken into several smaller features, and they can dip south. And then these ridges and troughs will determine where the cold air associated can go. You get more of a north to south flow in the jet stream, and it's usually a bit weaker. So extreme cold can follow wherever the polar vortex goes, but we can tell you that a season is favorable for such an event, but we can't tell you when just yet. So usually prediction time can be limited to under 2 weeks. Sometimes you can do a little bit better, but sometimes it's tough to get it under 2 weeks, just to be honest with you. So let's talk a little bit about the quasi-biennial oscillation. And those are winds in the stratosphere above the equator. In about an 18-month cycle, they'll switch from blowing from east to west like they did last year from west to east like they did last year to east to west like they're doing now and will continue to through the winter season. Now that usually by itself doesn't mean a whole lot, but if you combine it with a weak La Nina, there tends to be a couple of things that happen. The first is that we have a weaker polar vortex. Remember those winds at 60 degrees north, those on the right, those are some analogs of years that are have weak La Nina and the easterly minus QBO. And note those purples, that's below average winds, which means a weaker polar vortex. That gives you an opportunity for disruptions and a better chance. And a lot of times you'll get that later in the season, but that doesn't necessarily mean that it will occur. And if we break it down by month, look at December, there's an opportunity for some weaker winds there during that month. So and maybe an early season disruption as well. And then January, see those yellows come back. Maybe the vortex tries to recover. But in February and March, the analogs suggest that we have more opportunities for weaker winds or a weaker polar vortex. So what that means, of course, is early season disruptions could result in colder early winter temperatures, but that's not guaranteed. And then the late season disruptions could lead to later winter cold air masses or delayed spring warming. But that doesn't mean everybody gets it. It depends on exactly what type of disturbance it is, how strong it is, and where it is located. So the cold air could easily just go over to Asia or Europe and leave us alone, or it could come down our way. So even though we have these opportunities for disruptions, there's absolutely no guarantee that it will occur. So that's why the prediction time is high. And the model here is model guidance here kind of backs us up. Now this is the ECMWF on the left and the JMA on the right, two models with all their ensembles trying to predict it. So if you take a look at the thick black line, that is the average wind speed, and that's how we measure the strength of the polar vortex a lot of times. So note here that increases during the fall into the winter and then decreases after that. The thick blue line is the model average, and note here that starts to ramp up into November, but both models show a weakening towards the end of November into December and keeps a kind of a weaker polar vortex going for a while. Now, there's a lot of squiggly lines there. What that tells you is that there's a lot of disagreement within the members on the timing, but this is what's supposed to tell you is that there's potential for an early season disruption and potential for disruptions later in the season. So the models back up what the analogs are saying. Siberian snow cover, that's another thing we kind of look at, because if you have a lot of snow cover in October into November in Siberia, you tend to be able to grow some cold air masses there. So when we can get some of that to come down here, it can really deliver some cold. If you don't have it, then it's a lot harder to generate these really cold air masses to be able to come down. And so far through about mid-October, there's been a lot of snow in that region. And if that persists through late October into early November, which we expect it to do so, this correlates to the opportunity for high latitude blocking, and that can give you some cold risk overall during the part of the winter. And why does it matter? We take a look at the 5 highest snowfall years. Most of the time they're associated with a weaker polar vortex. You can see those purples, those weaker winds at 60 millibars yet again. But if you have they have low snow cover years on the right, notice how much stronger those winds are. So right now we're expecting it to be a higher snow cover year, although it's probably not going to be a top 5. But it's just another thing that tells us that there will be some potential for polar vortex disturbances this winter season. And we'll talk about this winter pattern signal emerging here in the model guidance and in the analogs. So we'll take a look at the analogs first. And we hinted at this already, but the analog strongly suggests a ridge in the Northeast Pacific through Alaska and a trough near Hudson Bay. And that's something that is kind of expected to repeat itself during the winter season. When you have that kind of pattern, with the ridges up in Alaska to warm them up, and then some of the colder air that's usually up there can be brought down into Canada and then distributed potentially somewhere in the central or eastern US. In this particular case, it does look like it's centered over the central US, and then you have kind of a southeast ridge. That's something we saw last year hinted at the guidance, and that's something that was observed. So there's another similarity to last year. The winter pattern signal is also shown on the model guidance. On the left, you see the same December through February 500 millibar height anomalies. The ridge here in the Northeast Pacific towards Alaska, and the trough west of Hudson Bay with a southeast ridge overall. So the ECMWF backs up the analogs very well. If you take a look at the CANSIPS, the Canadian model, the same exact thing shows up. So that's a pretty good signal. And this tells us that we're going to have another winter kind of like last year, where the cold is going to show up more often than it has in recent years prior. And with that, I'm going to send it over to our weather risk senior manager, Steve, and he can wrap this up into a forecast for us.
Apologize for being on mute there. Thank you, Nate. Thank you, Eric. We looked at the analogs, we looked at the model guidance, all the trends, and so this is how all that wraps up into our final forecast. So you can see here for November through March are month-by-month outlook of the temperature anomalies. And as Nate alluded to earlier, the higher risk for cold across the eastern half of the country is going to be in that November to January time period, whereas the higher risk for cold across the plains to the northwestern U.S. is going to be in the second half of the winter season, especially February through March, and kind of a kind of a split there between the eastern and western U.S. Now, we can't guarantee the coldest weather will be across the eastern U.S. Centered in the month of January. It could be the case that we see the cold in late December and early in January, or later in January into early February before the pattern trends warmer across the eastern U.S. But generally speaking, in that middle of the winter time period is a higher probability for seeing the widespread cold across the eastern half of the country, with lower risks as we progress into the latter part of the winter season. So for the December to February 3-month period as a whole, again, the north central US has the best chance to average below normal for that entire 3-month period. And the southwestern US has the higher probability of coming in warmer than normal for that 3-month period. But really, the entire southern tier of the country is more likely than not to come in warmer than normal for the winter season. But again, it won't be warmer than normal the whole winter. We do expect at least a month in that winter season to come in colder than normal across a good chunk of the southeastern quadrant of the country. And now in terms of HDDs, this winter season for both December to February and November to March is forecast to come in a little bit warmer than normal. And a good part of that reason is because the focus of the coldest anomalies for the winter average, you can see, is across the north central US, so not as big of a population area as, say, across the northeast or the south. And so if that colder air were to be shifted a little bit farther east, more into the Midwest, Great Lakes area, without really any change in terms of the intensity or overall pattern otherwise, that would boost our HDDs a little bit higher. So it's not just going to be a matter of whether or not it comes in colder, but just exactly where the cold is. A little bit of a eastward shift would have a big impact on our seasonal HDD totals. So looking at the warm and cold risks for this winter season, our current forecast is there in the middle, but we do have the potential again where if we don't see much impact from the polar vortex, we don't get one of those big cold waves in the middle of the winter season, we could see a good part of the eastern half of the country come in warmer than normal. And so that's our lower probability, but warm scenario risk there on the left-hand side. And if we do see everything be pretty favorable for the cold to develop midwinter, we could see a more widespread cold scenario that you see there on the right-hand side of the screen. Again, the strength of the La Nina will matter quite a bit. If we do see a stronger than expected La Nina, that would tend to make the warmer scenario more likely. Also, again, obviously, if we do see a big impact from the polar vortex, especially midwinter, that would make the colder scenario more likely to occur. So now looking at the HDDs a little bit more here, you can see the trend of the last 40 years. And so this year is still, again, even though it's below average, it does, by a little bit, it does look to still be colder than each of the last 6 winters in terms of our seasonal HDD totals. And notice that while it is below average, it's actually pretty close to the median of the last 40 years in terms of how it's going to rank out. So again, kind of a typical winter historically in terms of where our HDDs are looking to end up. And again, January does look to be the peak month and the month to have the best chance to see heating degree days come in higher than the long-term normal. Now looking at precipitation, you can see for November through March, there is going to be some variations in the trend. So the northwestern quadrant of the country looks to be wetter than average during November and December, but then trend drier than average, especially in January. The Northeast, again, could be pretty wet in November, but then pretty dry in January. The Great Lakes to the Ohio and Tennessee valleys could see periods of wetness in December, and then again in February and March. And so some variation from month to month here during the winter season, but the south central US, down towards Florida and across the Southwest, those areas are more likely to stay persistently drier than average. And so here's how the seasonal average looks. Again, the Great Lakes to the Tennessee Valley looks to be a wet area there, with a storm track likely going up through the Appalachians during much of the winter season. And then again, across the north central or northwestern US, mainly the northern Rockies area, could be a wet area as well. Looking at snowfall, Most of the northern tier of the country does look to be snowier than average this winter season. Again, the timing of that will vary across the northern tier in terms of, again, the northwestern US seeing more of that snow early in the winter, and then potentially more snow later in the winter as we head into the north central US. But also, we do have that area of above average snowfall from Oklahoma and Arkansas up into the Ohio Valley and across to the Tennessee Valley. And obviously, those areas don't typically see a lot of snowfall during the winter season. So a lot of that above normal anomaly would be effectively, one or two impactful snow or ice storms across those areas during the winter season, as opposed to maybe having none or one during a typical winter season. So we'll have to look for that as another possibility this winter season, like last year, to see some of that impactful winter weather getting a little bit farther south than is typical. But also notice the northeastern urban corridor from DC up into Boston, looking to see lower snowfall totals than average this year, but higher snowfall totals downwind of the Great Lakes. So we could still see a major nor'easter that is very impactful for the Northeast this winter season, but overall, the storm track looks to be a little bit farther inland, and that would tend to result in more storms that either stay on the rain side for the East Coast or see a snow to rain transition, and not as many storms that stay purely snowfall across the Northeast this winter season compared to usual. Now, looking at renewables, areas from the plains to the northwestern US, mainly the interior Northwest, Northern Rockies into Idaho, those areas in there should see more wind than average this winter season. The East Coast, with fewer coastal storms, likely come in a little bit less windy than usual. And the West Coast is going to be kind of variable. The seasonal average may be for below average wind speeds overall, but we could again see a series of storms cause above average winds during the first half of the winter season across Northern California to the Northwest, but then with fewer storms moving in later in the winter season as the storm track shifts, that may still cause the entire winter period to come in less windy than average, but basically higher winds early, lower winds late for that region there. And the solar forecast basically follows our precipitation outlook with more storms across that Tennessee, Ohio Valley, Great Lakes area, producing more clouds. The drier conditions across the Southwest, obviously looking to be more sunny as well. Now, looking at the global forecast, you can see here across much of Europe into the western part of Asia, above average temperatures. But like the eastern US, there is going to be some variability there. It won't be warm the entire winter season, but overall, the winter average does still look to come in warmer than normal. But eastern Asia could see some colder conditions for the winter average. More persistent cold is likely as we head into eastern areas of Russia, into northeastern China. So that will be a region to look for as well for potential, more long-lived winter impacts. So kind of summarizing things here across the US, across the Northwest, again, a potential for a stormy start to the winter season. The late winter period could end up colder and drier than average, however. Across the southwestern US, for the most part, again, most of the winter season warmer and drier than normal, most likely. The north central areas have the potential to be snowier than average and colder than average, especially January through March. The south central US may start out warmer than normal, but we do have the potential for cold during January and February in that area. Again, the southern tier of the US in general could see an impactful winter storm or two this winter, much like last year. Areas up across the Ohio Valley up into the Great Lakes could see a lot of temperature variability this winter season. Again, the north central US will stay more persistently cold. The southeast will see likely more warmth with the exception of January. And being in between there across the Great Lakes, Ohio Valley, likely a lot of swings back and forth. And all those storm systems moving through there will likely provide opportunities for above average lake effect snowfall as well. The East Coast, again, warmer than average for the winter across the southeast and up into the northeast at times. But again, January looking to be the best month to see colder than average conditions. But the overall pattern will favor a storm track kind of up through the Tennessee Valley into the Appalachians. And that likely will keep snowfall below average along the East Coast with fewer coastal storms, whereas again, the Great Lakes area could see more snowfall than average this winter season. So looking at some verification here, historically, we're at the end of October. Our seasonal forecasts are typically more accurate than the 30-year normal, 80% of the time, and more accurate than the 10-year average, using that as a forecast more than 70% of the time. And they'd be even a little bit higher than that if it wasn't for the fact that one of the winters was very close to the 10-year average and one was very close to the 30-year average, making the forecast a little bit harder to beat those years if you were using normals as a forecast. But overall, that kind of gives you an idea of the typical verification of our forecasts at this point in the pre-winter season. So kind of summarizing things here, again, a big factor this winter is the weak La Nina that is in place across the Pacific Basin, and how strong that becomes in the next couple of months and how fast it weakens will be a big factor in terms of how the winter season evolves, especially the second half of the winter season. Our forecast does lean towards those years that were similar to this year that did have some colder risks across the early part of the season in the central and eastern US. And so that is, again, something we're looking for the potential for a December, January cold wave across the eastern part of the country. A lot of variability in temperature is typical for La Nina years. Oftentimes you see the strongest cold waves during La Nina winters. So even if you do see the southeast average warmer than normal, which is typical during La Nina, a lot of times you get some extreme cold during those winters as well. Even Florida typically sees more or most of their freeze events happen in the citrus areas during La Nina winters, even though they tend to average warmer than normal, because you tend to get that one big cold wave more often than not during these types of winter seasons that impact areas deep into the south. Again, the East Coast could end up warmer later in the winter season, whereas northwestern US more likely to stay cold late in the winter season. So some regional differences there. And again, snowfall will be typically above average the way it looks from the Great Lakes to the Northwest, the East Coast, most likely below average. So looking at a few industry impacts before we wrap up and take some questions. On the utility side, again, a lot of temperature variability likely this winter season for much of the country. So big extremes, some big cold waves, some very mild periods in between. And again, those will create a lot of week-to-week variability, which could have some large swings in demand on that week-to-week basis. And the extreme cold waves that get into the south at times could have or could produce some very sharp bursts of demand across those areas. And if they do come along with a significant winter storm, snow or ice in the southern US, that could also be accompanied by the potential for power outages, downlines, that kind of thing, if we do see some ice storms in those areas like we saw last year. Again, the East Coast itself may see fewer coastal storms, which may reduce some of the threats there in the major urban corridor. But at the same time, we could still see periods of heavy rainfall and snow, especially as we head to the Appalachians and farther west. In the Northwest, again, could see some big storms in the first half of the winter season, but lower risks later in the season there. On the aviation side, again, with the pattern that we're expecting, the northern tier of the country is going to see the bigger winter impacts most consistently. And so that's going to be the region that sees all types of impacts to aviation, from winds to snow and ice impacting airports in those areas, whereas the southern US, and generally speaking, less precipitation, warmer conditions, overall fewer impacts. But again, we are expecting, though, that we could see a couple winter storms impact the South this winter season. So areas from Texas to the Tennessee Valley, there could be a couple of periods this winter where we do see some impacts to aviation from winter weather. On the transportation side, again, one area to look for will be the heavy lake effect snow around the Great Lakes. So places like Buffalo, could have a good year for seeing a lot of snow, which could have some big impacts on transportation, but potentially fewer impacts than usual along the urban corridor of the Northeast. But Chicago, Minneapolis, those areas in the Midwest could also see higher snowfall and bigger transportation impacts this winter season, as well as across the northwestern quadrant of the country as well. Now, on the offshore side of things, we likely will see a lot of frontal passages make their way into the Gulf this winter season. So lots of periods of strong winds, higher waves across the Gulf. At the same time, though, we could see fewer days of impactful ocean conditions across the East Coast with fewer coastal storms. So while it's always stormier in the winter season than other times of the year, typically we should see more of those storms stay away from the coast, and thus the overall impacts from winds and high waves will likely be a little bit less than is typical during the winter season there. And with the frequent frontal passages across the Gulf, that may actually help to reduce the amount of days we see with fog in the terminals there, like in Houston to Mobile Bay. So could potentially see fewer fog impacts, but just higher wind and wave impacts across the Northern Gulf this winter season. So with that, we can open things up to questions. You can again see our summary for the winter weather: cold north central overall, but cold potential for the east, especially as we head into the month of January. And again, potentially a snowy winter for the north central and northwestern US, and potentially a storm or two as well that could be impactful across parts of the southern tier of the US. And so with that, Nate, have we had any questions trickle in so far?
Yeah, thanks, Steve. Yeah, we've had some questions trickle in. Let's start with our first one. How much later is the coldest 90-day period? How's it shifted over time in comparison to historical periods? Not 100% sure which part of the country we're talking about here, but let's assume the East.
Yeah, I can look at that. Obviously, we have seen some trends as we showed in some of those maps. Or I think Eric showed those, showing how like the north central US has seen a tendency for colder late winter conditions. I think February to April has been trending colder across the north central US. So there has been sort of a later or a trend towards a later start to the coldest 90-day period for there, and even across the eastern US in general, because we have had a tendency in many of the recent winters to have very, very mild Decembers. That's kind of forced the coldest 90-day window to be a little bit later. That doesn't actually, it's a little bit sometimes deceiving, because it doesn't mean it's actually colder for parts of the eastern US than average, or colder than what it's been historically, like say January to March. It's just that because December has been warmer, it's kind of shifted that window of when the coldest 90-day window occurs. It's just kind of warming up the front end, leaving everything else the same, has kind of caused that window to shift later in time across the eastern US. There hasn't been as much of a trend in that direction across the western US, although parts of the northern Rockies have also seen a little bit of a later shift because of the tendency for some additional late winter cold in like Montana and Idaho and those areas in there.
Yeah, that makes a lot of sense. Thank you, Steve. Next question up is, what is your temperature and precipitation forecast for the prairie region of Western Canada? And I'll take that one. Like like neighbors to the south, there will be a lot of volatility this winter season. I think it'll start out cold. I think there'll be some opportunity for some Arctic air into the Canadian prairies pretty early. So below average temperatures in December, and then probably repeats itself February into March. But I think there'll be some opportunity for some very warm midwinter temperatures. So lots of ups and downs that might average somewhat below normal in that part of the world. Far from a precipitation standpoint, I would say we're going to average close to the normal. Have some dry periods and wet periods, kind of balance each other out. But I do think there'll be enough snowfall to at least get some snow cover down in those areas, and especially to get early period and then kind of later in the winter as well. The midwinter period might see some of that diminish once it warms up. And next question up. Do we expect to see a lot of ice storms this winter season?
So yeah, as I mentioned a little bit, there is, or at least alluded to, the potential for some impactful winter storms across parts of the South. One thing that you can sometimes see with a storm track like we're expecting, that, and it kind of goes from the south central US up through the Appalachians, is the potential to have more of those icing events even in the northeastern US. So while we do have a heightened risk for potentially seeing some ice storms across parts of the South, especially northern Texas up into the Tennessee Valley, a lot of times with these types of storm tracks, you see in the Northeast, a situation where you have snow at the start, and then you transition to a period of ice, and then you see a transition to rain as those storm tracks, or as those storms track up the Appalachians. And so a lot of times you can get a lot of these transitional storms that produce quite a bit of ice, or at least or frequently produce ice across the northeastern quadrant of the country. Not necessarily the same kind of ice storm you see in the South, where it's just you have Arctic air in place and you have just a lot of rain falling in the Arctic air, and the whole storm is cold. A lot of these storm tracks that we see in years like this across the Northeast are those, transitional storms where you get ice, but then it warms up and turns to rain. But you still can potentially see some very impactful ice accumulations in these types of storms too. So we'll have to watch the Northeast for seeing some of those at least short-lived ice events during the transition from snow to rain with these inside runner storms as I track up through the northeastern quadrant of the country.
Yeah, great insights. I can't argue with any of that. That is with the kind of wild temperature swings and the changes in regimes, that kind of thing can happen up there. So have to keep a close eye on that as we keep getting more change. Next question up. How will all this impact the tornado season for next year, for next spring? And I can take that one. A couple things. First of all, I still think, even though that the La Nina event will weaken during the winter season, I still think that it'll have enough of an impact on the circulation to get things going early. So with a cooler air in the west and north and warmth in the south and east, I would anticipate that we're going to start out pretty quick across the south central part of the country into the Ohio and Tennessee Valley Gulf Coast, especially the further south one goes. So I think we're going to get a pretty active start to the season. So we'll have to watch out for that. But as we get towards the latter part of the season, maybe May into June, especially if we can get anything close to El Nino by the time that occurs, we might see things slow down a little bit. That's tough to say. That's pretty far out at this point, but this could be a front-loaded tornado season. But overall, I would anticipate it to be above average in nature. And let's see. Next question up. What are some other analogs in addition to 24-25? We consider ENSO and QBO outlooks can we get a good idea of the polar vortex strength and the cold snap temperatures we might see. I can pull up our analog list here real quick. But let's bear with me for one moment. All right. Other years that we have, last year we focused on quite a bit, 24-25, but also 21-22, 08-09, and 17 and 18, and 22 and 23. Those are some other ones that we figure will carry a lot of weight. And if we take a look at some of those, there were opportunities for the polar vortex to be weaker. In this particular case, I think we're going to see it be a little bit weaker than some of those other years, because some of those other years weren't exactly a match. There's no such thing as the perfect analog. Even with a good one like last year, there are some differences. Like the QBO was different. That was positive last year when we had a stronger polar vortex through most of the year. Yet we still had some of the cooler outcomes, and we had a late season disturbance, even though it was stronger. So we had those types of things. And like I said, with those, timing everything out in terms of polar vortex disturbances, and then timing the associated cold and where it's going to be, it's almost impossible to do this far out. The only thing we can do is take a look at the analogs, and they can show us that there are opportunities sometime that the polar vortex could be weaker and the disturbance could occur. So the more opportunity you have, the more alarm bells you want to ring for the potential for cold. Now, could that easily happen on the other side of the pole? Yes. So it could be for Asia and Europe instead of us. So we're going to have to see as each individual one comes up. And yes, 2024, 25, 2021, 2022, 2017 and 2018, and 2008 and 2009 are other examples of good analogs. All right, I think we're getting to the top of the hour here, so I think I don't see any more new questions, so I'm gonna turn this back over to Andrea, and she can close us out for this webinar.
Thank you so much. Thanks, Eric, Nate, and Stephen, for all of your updates today. Like I said in the beginning, we have recorded this webinar, so we will send out a link to the recording, along with a link to an infographic that summarizes everything that we went over today. So be on the lookout for both of those things to your inbox, probably by no later than Tuesday of next week. So if you have any remaining questions for us, feel free to either put them in the chat, and we can address those as we need. So with that, thank you very much. And we look forward to our mid-season update in January. So also look for those invites coming out as we get closer to that date. Thank you.